Hello and welcome everyone. I'm Amit Kumar Mishra, and today in this short video presentation we will learn about the gravitation. So in this chapter we shall learn about the gravitation, we shall learn about the universal laws of the gravitation, we will learn about the motion of object under the influence of gravitational force, and we shall also learn about the variation of weight from place to place. So we always observe that an object dropped from the height appears to fall towards the center of the earth, and we also know that different planets revolve around the sun, and also the moon revolves around the earth. So in these cases there must be a force which governs these movements, and these movements were first explained by Sir Isaac Newton in a holistic view, and the force responsible for these movements is called as gravitational force. According to the universal law of the gravitation, if there are two objects which are having mass capital M and a small m, and the separation between them is smaller, so there acts a force which is directly proportional to the product of their masses, and this force is again inversely proportional to the square of distance between them. So if we add these equations first and second, we get the complete force acting on the object, that is F equals to G capital M small m upon R square, where capital G is a constant which is a universal constant, its value remains constant everywhere. Now we have to calculate the force between Earth and the Moon, where the mass of the Earth is given, mass of the Moon is given, and the distance between the center of Earth to Moon is given. They are also provided with the value of universal gravitational constant. So if we keep these value in the formula, we get the force acting between Earth and Moon is 2.01 into 10 raised power 20 newtons. By universal law of gravitation, we can explain our binding to the Earth, and we can also explain the movement of different planetary bodies. We can also explain the origin of tides with the help of these gravitational forces. We know that Earth attracts any object towards its center because of the gravitational force. So whenever an object falls towards the Earth, under this force alone, this type of fall is called as free fall. In this particular scenario, we are neglecting any overall air drive or air resistance. So in this particular case, the weight of the object, that is because of gravity, and its mass will be equals to the gravitational force acting on that particular object. So that's how we have the value of acceleration due to gravity small g equals to capital G m upon r square. We can calculate the value of gravity by putting the values of universal gravitational constant, mass of the earth, and radii of the earth in this particular formula. So while we solve it, we get the value of gravity as 9.8 meter per second square. We can change the laws of motion for the object under the influence of gravity by changing the acceleration value from a to g. So we have different equations of the motion under the influence of gravity. V equals to u plus ct, h equal to ut plus half gt square, and b square is equal to u square plus 2gh, where b is the final velocity and u is the initial velocity, t is the time taken, and small g is the value of gravity. So these are some numerical examples which are based on the motion of object under influence of gravity. Mass is an intrinsic property which is actually the measure of its inertia. If we have larger object which is having larger mass, it is going to provide the greater inertia, and if we have a smaller object which has a smaller mass, that is going to provide the smaller inertia. And mass, because it is intrinsic properties, it is going to be same everywhere, whether we measure it on earth, we measure it on moon, or we measure it anywhere in the outer space. While the weight of object is the force by which any particular planet attracts it towards its center. So in case of earth, the weight of object is going to be the mass time gravity of the earth. Because this particular weight is dependent on the value of gravity, so it is going to vary from place to place. For example, if we are going to measure the weight of object on the earth, it is going to be different. If we are going to measure the weight of the same object on the moon, it is going to be different. So now let's compare the weight of object on the moon to the earth. So let's say that weight of the object on the moon is Wm and weight of the object on the earth is We, and the mass of moon is mm and mass of earth is me, radius of moon is rm and radius of earth is re. So these are the values of mass and radius of the earth. If we put these values in these particular equations, so we get Wm by We equals to 1 by 6. So that means if we measure weight of object on moon, it is going to measure 1 by 6 times the weight of the same object on the earth. So let's see some numerical examples. Mass of the object is 10 kg. What is the weight on the earth? If we multiply this mass by the gravity value of the earth, we are going to get the weight of that object on the earth, and that is going to be 98 Newton in this particular case. Here we have one other question. If the object weighs 10 Newton on the earth's surface, what will be its weight on the moon? So we know that weight of object on moon will be 1 by 6 of the weight of the earth. So that's how we have weight of that particular object is 1.67 Newtons. All the graphics and diagrams for this particular lecture has been created using Office 365. So in this video presentation, we have learned about the gravitation, we have learned about the laws of gravitation, we have also learned about the motion of object under the influence of gravity and also the variation of weight at different places for the same object. Thank you. Jai Hind.